Hi everyone, and welcome to this video where I'm going to be talking about endo and exothermic reactions, which is really around heat changes during a chemical reaction. Okay, so before we start, we really need to talk about this concept of heat energy. And in a chemical reaction, we call it enthalpy. The enthalpy, which is given the chemical symbol H, is talking about heat energy, and in particular we're talking about the heat energy of a particular chemical reaction. Like all types of energy, it's measured, well, energy is measured in kilojoules. Because this is about a chemical reaction, we're talking about kilojoules per mole of reaction. So one chemical, like when you write the chemical reaction and it's nicely balanced, then that is considered in the ratios that are written in that chemical reaction to be 1 mole of reaction. And we really talk about the change in enthalpy. So we're looking at the difference in enthalpy between the reactants and the products. Okay, so the reactants will have a certain amount of heat energy, and the products will have more or less heat energy. So if the products have more heat energy than the reactants, heat needs to be put in. It comes from the surroundings. And if the products have less heat energy than the reactants, then heat is released out. Now, the other thing to remember is that each chemical bond contains a certain amount of enthalpy. So that is the energy required to make or break that bond. Okay. So we can look at the energy change in a chemical reaction in a visual way, and that's what these two graphs are showing us. And they're called energy change diagrams because they show how the energy changes in a reaction as you go from the reactants to the products. Now there's a couple of things you need to see in here. First one, you'll see we've got a green line showing the energy of the reactants and a second green line showing the energy of the products. Now the reactants might have a higher energy than the products or a lower energy than the products. You'll see there's always a hump in these graphs, and that is the activation energy. Now the activation energy is possibly not a concept you've come across yet unless you've done chemical reactivity. Activation energy is the amount of energy it requires to get a reaction started. Some of them don't require very much at all, some of them require a lot. So you've got the activation energy, so you start with some energy in your reactants. You put some energy in just to kickstart the reaction, and then the reaction proceeds and the reactants turn into products, and the products have a different amount of energy. The difference between the starting energy of the reactants and the final energy of the products is called the overall energy change or enthalpy change, delta H. Now, on the left-hand side, we have one where the reactants basically lose energy as they're converted into products. And this type of reaction is called exothermic. Exo means exit, leave, whatever. Thermic relates to heat. So an exothermic reaction is one where heat energy leaves the reaction system. So the reaction system itself, we're talking purely about the particles that are reacting. Everything else is the surroundings. So in chemistry, we talk about two concepts, system and surroundings. So the system is just the reactant and product particles. That's all it is. So it's not the water that they're occurring in. If it's an aqueous solution, it's not the air in the surroundings. It's only the reactant particles and the product particles. So everything around them is the surroundings. So if heat is being lost from the as we go from the reactants to the products, if heat is being lost, that heat is going out into the surroundings. That might be the water if it's an aqueous solution. It might be your hand if you're holding onto a test tube. Those are all the surroundings. So they're going to get an increase in heat energy because it's going out. The reverse is an endothermic reaction, so heat is coming into the system. That heat that comes into the system has to come from the surroundings. So from the water, from your hand, from the air. So an exothermic reaction is one where the surroundings get an increase in heat, so they get hotter. Whereas in an endothermic reaction, the surroundings get colder, and that's really important. Here's the same concepts, just written in words if you like the notes, okay? As enthalpy, heat energy is released from the reaction, the surroundings get hotter. That's your exothermic reaction. If the enthalpy, heat energy, is absorbed from the surroundings, then the surroundings get colder. And that's what we call an endothermic reaction. Both types of reactions are relatively common, but spontaneous reactions are ones where we go from a higher energy state to a lower energy state, so we need to put less energy in. Now, there's more than one type of energy involved in a reaction. Enthalpy is only one type. We'll talk about the other one in year 13 when you get to that point. But it's just important to be aware that, in general, an exothermic process is more likely to be spontaneous than an endothermic process. Okay. So the sorts of things that are exothermic processes include any reactions that involve bonds forming. That can include state changes where bonds are forming between the particles. So as we're going from a gas to a liquid or a solid, so condensation, freezing, reverse sublimation. Of course, as soon as you hear that the surroundings get hotter, then you know it must be an exothermic process. That means that any combustion reaction, combustion of course being burning, must be an exothermic process. Last time I was trying a combustion reaction, my surroundings got hotter. Okay, and mathematically we can calculate the change in enthalpy, delta H. And in an exothermic reaction, that change in enthalpy will be a negative value because the enthalpy of the reaction, within the reaction itself, we're going from a higher energy level to a lower energy level, so the amount of enthalpy contained in the system is going to decrease. Of course, endothermic reactions are the reverse of that, so anything where bonds are being broken. Okay, could be changes of state. So if you're going from solid to liquid, liquid to gas, you're breaking those intermolecular bonds. So those are going to be endothermic processes. The surroundings will get colder, and your delta H value, your change in enthalpy, will be a positive number because the products have a higher amount of enthalpy than the reactants. Okay, so just to be really clear, when we're changing state, remember, if we're going from a solid to a liquid or a liquid to a gas, the particles are moving further apart, they are moving faster, and they usually have to gain energy. Okay, these are endothermic processes because effectively we're breaking bonds. We're breaking those intermolecular bonds between the particles. If we're going the other way, so we're going from gas to liquid or liquid to solid, the particles coming closer together, we are forming bonds between the particles, and therefore energy is actually being released. Now that's one that's harder to see, but just take my word for it. Okay, so just to be really clear, when we're looking at change of enthalpy values, in an endothermic reaction, heat energy is being absorbed by the system, so by the reactant particles, from the surroundings. So heat is going from the surroundings into the system. That means the surroundings are going to get colder and the products are going to have more heat energy than the reactants. In an exothermic reaction, it's the reverse. So the heat energy is being released by the reaction system into the surroundings. So the surroundings are going to get hotter. The reaction system itself is going to have an overall decrease in energy because as you go from reactants to products, the heat energy is going to decrease. And therefore, the enthalpy change is going to be negative. Now, these sorts of questions, or questions about whether or not this reaction is endo or exothermic, come up regularly in NCEA. And I'd like to briefly show you the sort of question that you can see and what you should do to answer it. Okay, so these are some questions out of the 2018 exam paper. You can find these exam papers on the NZQA website, and of course their mark schedules can be found there as well. So question 1A here talks about the equation for dissolving of ammonium chloride. Ammonium chloride in solid turning into aqueous ammonium ions and chloride ions, and you're provided with a delta RH value there beside it. So change in enthalpy is plus 17.8 kilojoules per mole. Circle the term that describes this reaction. Well, and give a reason. I'm going to talk about those together. The most obvious thing, the enthalpy change is positive, therefore the reaction must be endothermic. So you're going to circle endothermic, you're going to give a reason. The reason is simply that delta RH is a positive number. Okay, and then respiration is the process by which energy is released from glucose. There's the formula, circle the term. Now, here's the key word, energy is released. It says it in the question. So this must be an exothermic reaction. It's exothermic because energy is being released. That's the only reason you need to provide. And finally, here's the last part. Water formed in the respiration reaction evaporates, liquid to gas. Explain whether this process is endo or exothermic. Well, we're going from a liquid to a gas, so we're breaking the intermolecular bonds between the liquid water molecules. Therefore, this process must be endothermic because we are breaking bonds. I hope you found this useful. Endo and exothermic, it's all about heat energy. Hopefully I'll see you soon in my next video. Bye.